Okay, so probability of whatever it is that's happening is always equal to the number of outcomes over the total. So a fair coin is tossed 3 times and comes up heads every time. What is the probability that on the next toss it will come up heads? What do you guys think? Isaac? Yes. Do the first 3 tosses affect the probability of that next toss? No. So it doesn't matter what it says in that sentence. We could toss the coin 1,000 times, and we still have a 1/2 chance on the next one, right? Thanks. All right. So when you guys write your answer, all right, we're going to have P of getting a heads. So P of heads, probability of getting a heads, is 1, because one side has a heads, out of 2, because there's 2 total sides on the coin. Right? That's it. Okay. A fair coin is tossed 3 times. What is the probability it will come up heads all 3 times? This is a different question, because we're not just saying the next toss, right? We're saying 3 tosses in a row. What's the probability that if I toss it 3 times, I'm going to get a heads every single time, all right? So for this one, we have the probability of getting a heads, comma, heads, comma, heads. So I want to see it written like that. If you want to put H, comma, H, comma, H, you can. All right? So whenever you have a probability of something happening over and over and over again, we multiply those probabilities. So what's the chance of getting a heads on the first toss? It is 1/2. What's the chance of getting a heads on the second toss? It is 1/2. What's the chance of getting a heads on the third toss? It is 1/2. So that final answer is 1/8. Okay. So you have a 1 in 8 chance of getting a heads 3 times in a row. Okay, so think multiplication when you're doing a bunch of them at one time. A single die is rolled 3 times. What is the probability that the next roll will produce a number greater than 3? So do the first 3 rolls matter on this particular problem, you guys? No. Okay, the first 3 rolls don't matter because we're not saying what happens every single time. We're saying, okay, we rolled it 3 times, that doesn't matter. But what's the probability that the next one will get a number greater than 3? So when you set up your probability that I want to see, you can write it like this. Probability of getting a number greater than 3. So a dice has how many sides? 6. And so we have the numbers 1, 2, 3, 4, 5, 6. So which numbers are greater than 3? 4, 5, 6. So the total outcomes that we're looking for, the favorable outcomes, are a 4, a 5, or a 6. So the chances of getting a 4, 5, or 6 would be 3 out of the total 1/6. Which reduces, and you always reduce your probability problems to 1/2. Okay, what would be the probability of getting a number greater than 4? 2 out of 6, which reduces. What would be the probability of getting a number greater than 5? 1 out of 6. Okay. All right, 2 dice are rolled. What's the probability the sum of the numbers rolled is 6? This one is a little more challenging. Every time you guys see the 2 dice problem, you have to draw this picture out, all right? So it's going to be a pain, but this will help you remember it forever, which you're going to need in Saxon. Okay? This time we're rolling 2 dice. So for one of the dice, we can get a 1, 2, 3, 4, 5, or 6. And for the other dice, we can get a 1, a 2, a 3, a 4, a 5, and a 6. Okay, those do not count towards our actual probability because we have to find the sum of the dice. What is the probability that the sum of the numbers rolled is 6, right? So if we roll a 1 and a 1, we roll the snake eyes, what's the sum going to be? 2. So the smallest you can possibly get is 2. All right? If we roll a 1 and a 2, the sum would be 3. If we roll a 1 and a 3, the sum would be 4. And so on. So you guys can fill this whole chart out, right? A 2 and a 1 would give me a 3. A 2 and a 2. So 5, 7, 8, 4, 5, 6. Okay, you have to do the table neatly to make it work here. All the way to a sum of 12. The biggest number we can get is if we roll a 6 and a 6, and therefore we get a 12. I'm going to pause. All right, so first of all, we need to write our probability. So we need the probability that the sum is 6. Okay, probability of getting a 6 when we roll 2 dice. So how many total outcomes do we have here? There are 36, and there are always 36 choices because we have 6 answers this way, 6 answers this way. That's 36 total choices. So whenever you're doing a sum of 2 dice problem, it's going to be out of 36 different outcomes. That's how many outcomes we can get. So we want to know the probability of getting a 6. How many 6s are there? Yes. So my answer is 5 out of 36. Does that reduce? No. All right. So every time, you guys, I need to see this on your sum of 2 dice problem. All right, let's try another one. An urn contains 6 pink marbles and 7 blue marbles. A marble is drawn and dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were pink. If another marble is drawn, what is the probability that it will be pink? Do the first 2 draws matter? No, but it does matter that we replaced our marbles. That matters, that we put them back in the urn, okay? So another marble is drawn. What's the probability it will be pink? So probability of getting a pink marble. Well, how many are pink? 6. How many total marbles? Yeah, you add these numbers together. That's it on this one. That's easy. Okay. All right, the spinner shown is spun 3 times. What is the probability the spinner stops on 2, then on 4, then on 3? So this is 3 probabilities happening, just like the problem where we toss the coin 3 times. So what are we going to do with our probabilities? Multiply them. So the probability we get a 2, a 4, and then a 3. What's the probability of getting a 2? 1/4. What's the probability of getting a 4? 1/4. What's the probability of getting a 3? 1/4. So that's all going to equal 1/64. Okay, let's try it on the whiteboard.